test today on the Epoch battery, just the 12 volt 100 amp hour battery, just the typical standard 100 amp building block here. We've got a couple of them back there. We've got our cheap inverter. This is a 2000 watt inverter off of Amazon. We have a old school heater. We have an old school heat lamp. Right now it's still charging. I'm going to disconnect that charger in a minute to make sure we're not skewing our results. But right now we are still topping off. This is the Epoch app. Excellent app, best I've seen. Still topping off at 14.99 amps, which that charger over there is a 15 amp charger. We've got 106 amp hours packed into a 105 amp hour battery. These are actually sold as a 100 amp hour battery right here, but they're not. They're 105 amp hours. It says 1.28 kilowatt hours. We have 1441 packed in there and still drawing 14.99 amps. It says 0 minutes. We're at 100%. Should kick off any second. I think at the top of the cycle it will do some balancing. Right now our voltage difference between the cells is 0.007. That's probably going to go down here in just a little bit. There's our cell voltage max, cell voltage minimum, and average. That's how many watts is coming in, voltage of the pack, and total amps coming in. So down here is the temperatures. 82, 82. I think these are MOSFETs or some sensor on the MOSFET. 86, ambient temperature 86. These are the actual cells voltages. So what we're going to do is we're going to, as soon as it's topped up, we are going to disconnect the Epoch charger. This is still charging. And then when it's done charging, I'll disconnect that, so we remove the 15 amps going into the battery. So that way we've got a DC clamp meter. This is a pretty decent, well, it's a cheap clamp meter, but it's a good cheap clamp meter. It's not a fluke like this. But I did some research and this is the best of the cheap. It's a pretty good cheap clamp meter, and so we'll be measuring it there, the actual amps coming out. We'll compare it to where it says total amps right there, that's the charge current. It will have a negative number when we start drawing amps. So we have this old school heater, and several 100 watt bulbs. I don't know exactly how much we're going to be pulling out, but I want to ramp it up and see what we can pull out. So the basic rating for these batteries, for this 100 amp hour batteries, it doesn't say it on here on the box, I guess. Continuous rating on this battery is 120 amps of continuous amp output. For peak values, it is 200 amps for 60 seconds. Now, if you've ever seen charts on peaks for things like generators or batteries or electronic equipment, the 200 amps at 60 seconds, 60 seconds is a long time. So for instantaneous peaks, you can assume safely, and this is not Epoch speaking, this is just me speaking, that you can assume that that's going to exceed or be capable of pretty far exceeding 200 amps for shorter durations than 60 seconds. Without some pretty good equipment, we wouldn't be able to test what those peaks are, because everything happens so fast. Peaks go up and then they drop when you have a peak load like that. So we're not going to be able to test it. But what we can test is the continuous rating. So we're going to exceed the continuous rating on this battery by a pretty decent margin. And we'll measure all that. We'll see what we can get out of this. I think I'm just going to stop charging here. So we're still at 106 amp hours. I'm not really drawing too much right now. I mean, still 15 amps, but we got to be very close to the top here. So let me shut off the charger. Okay, Fan stopped spinning. These are nice little chargers. Also, if this does overcurrent, I want to see what that little tethered monitor does. It should give us a warning if we can overcurrent it. So we're going to start. Okay, we got 0 amps there, right here, and no watts being pulled. So let's flip on this inverter. Got a heat lamp, that is on. We got 2 bulbs. So what are we showing? We're showing 163 amps being pulled. Whew, this inverter may not survive. 2,135 watts. So I guess I can't push it anymore. It's dropping a little bit, so hopefully we'll stay within limits. So I'm not going to be able to push it much more than this. We're still pulling 163 amps. Let's see what our meter says. Our meter says 161. 160. Dropping slightly. If it goes down, I'll plug in another bulb. We're at 2,060 watts and dropping a little bit here. So the battery, I think we started at, we can look back in the video, but I think it was either 13.6 or 13.8 while it was charging. Battery holds good voltage under a huge load, 12.4 volts. So we're still pulling 159 amps there, 158.9 there. So they're pretty matched up. And I don't have a timer running. I really should have put a timer on. But we can go into here, into this mode here, more, go to historical data, and we'll be able to see in real time how much we're pulling. Current, so this must be the current here. Okay, so that's where we started pulling 161. So right now we're logging this time. Well, I hear things clicking and popping over here. I guess that's just the heater heating up. So where are we at here? Let's go back to our other data device. And we are still pulling 158 amps. Endurance time is 37 minutes because we're crushing this thing. You know, you got to figure if it's a 100 amp hour battery, you can pull 100 amps for 1 hour. And here's our capacity. And you can just watch it drop because we are hammering this thing. Let's look at our temperatures. Temperatures are rising. 93. The MOSFET's 109. I don't know what the over temperature is. And I'm in Florida and it's pretty warm out. I would say it's about at least 80 something in this garage. So you can see that MOSFET heating up there. Voltage is still holding strong. Calibrated meter still holding. Let's see here. 2,000 watts. Yeah, I don't want to plug in another light bulb just yet. Those are 100 watt light bulbs, but my poor little inverter's getting crushed. And look at the voltage difference between the cells. You know, here's the cells. This just shows the voltage difference. 0.009, not 0.9, not 0.09, and it's going down. Like it just went down to 0.08. That's amazing. So we have been exceeding the amps, rated amps, by over 40 for a few minutes now. Let's look at the temperatures. Actually, the internal temperature is kind of stabilizing. The MOSFETs are going up. Already, it's impressive. And this is not to be condoned. This is not for you to design something to pull 160 amps on everything you do. I just want to see it. You know, I've got a fire extinguisher behind me. If something happens, I'll toss this thing out in the street. Or I have a hook up there. I'll just grab it by the hook and drag this whole contraption out in the street, in the cul-de-sac. Or I have a lake in back too. I could do that. But so this is not, you know, just because it can do it doesn't mean you should. I'm just doing it for this video and for everybody to see. put down the challenge out there for anybody that has other batteries that wants to test them in this way. Maybe I shouldn't do that. Somebody might burn their house down or something. We don't want to do that. But I'm doing it to mine. Still pulling over 160 amps. Still holding a solid 12.3. 87% left. This says 12.7, but I am measuring this at the battery terminals on the other side of those. Let's see, we got anything hot up here? No. A little warm. These are 4-aught cables. I don't know how long I'm going to do this. We'll see. Still have 87% capacity. Just hammering it. Let's look at our temperatures. MOSFET's up to 132, so that's going to be the limiting factor, I believe. Is, you know, I don't really know what the internal parameters of the BMS are set to. If it measures actual current, I suppose it does, or is it just going to be a MOSFET over temp first? I could go up on current more, but my little cheap inverter probably couldn't take it. Let's watch that temperature for a little bit. 136.4, 138. Battery's just slightly warm, but there's a lot of space in there. 140. It's warm. Voltage is still barely dropped, holding strong, still over 160 amps. Our little meter up there is missing a couple segments now. 143 on the MOSFET. We're shooting out 255 watts. I'm sorry, 2055 watts. This is more than what comes out of a plug, typical plug. I think they usually cap what, 1500, 1800 watts, something like that. How's my little inverter doing? Actually, it's doing okay. While we're waiting on this, just a word of caution when you're pulling high amperage or using lithium batteries, and if you make your own cables, or even if you don't make your own cables, it's a good idea to get like a laser temp sensor, or better yet, like an infrared gun. I have a video where I use an infrared gun. You can go look that up for a cheap infrared gun, and shoot your cables after you have a battery installation like this. If it's on a boat or a golf cart or something that's gonna, you know, a van, camper, something like that. When I first hooked this up and I pulled over 100 amps, this particular terminal got extremely hot. It wasn't the fault of the battery. This terminal had some kind of coating on it, a light dusting of something. I'm not sure what it was. Could have been anything. And as soon I just took this, actually that's why this is out here. It's just a sanding block, and this is where I did it right here. I just sanded that off on both sides, and for good measure, I just sanded the top of the battery lightly, very lightly, cleaned it with some alcohol on both sides, put it back together, and it's perfect. But it was quickly, you know, in a scenario like this, that terminal was quickly getting not red hot, but too hot to touch, and it would have continued. This was after just 15-20 seconds. So it's a really good idea when you're working with a battery like this, especially when you start stacking these banks in parallel and you're pulling very high currents. Take a look at all of your terminal ends and these flat pieces that fit together. Make sure they're flat, make sure they're very clean. Possibly take something like this and just lightly sand them off so that they're very, very clean, because it doesn't take much of a poor contact and these things will be smoking. So, and look at these cheap contacts over here. I had to they have two sets of contacts, so I made these smaller cables to go around. These are okay. It's hot in here. Get all this heat. Let's see what we're at 159 on the MOSFET. MOSFET temp still climbing. Right here. Ambient temp of the surrounding, I'm assuming this is like the surrounding air in the case is climbing as well. But I think this T1 and T2 are buried between the cells and they're doing just fine. Obviously the cells have a lot of mass. It's going to take a while for heat to transfer to them, but the cells themselves aren't heating up significantly. That MOSFET's dealing with all the current. 69%, still pulling over 160 amps. Endurance time 26 remaining, but it looks like we're not going to have an overcurrent. My guess is we would have an over temp of the MOSFET first, but I don't know what those are set at. I think you can go in here and you can go on this website or the operations manual and you can get a little bit of information. So let's see, we started this at 2112 roughly, pulling a bunch of current, 160, and we are currently at 2125, so it's been about 13 minutes and change probably. You see the capacity, that's the capacity dropping. Actual capacity, we were at 106 there, we're at 70 here. Voltage here was 0 amps, 13.5, and then it started getting hammered with 161 amps. Voltage dropped to 13. Okay, let's go back. Device. So 24 minutes remaining. Are we gonna make it? Whew, MOSFET's up to 172. Still pulling over 160. Still holding strong at 12.25. On here we got 161 and 12.6. Still pulling over 2,000 watts. So this could certainly run just about any little cooktop, induction cooktop. Most of those, like a single induction cooktop if you're camping. Most of those are going to be less than 1,600, 1,500, probably more like 1,200 watts, which would be fine, and you could cook for a considerable amount of time on a single battery. Now, from what I hear, Epoch is supposed to be coming out with some monster 12-volt batteries for van life or camping, or what I'm interested in, of course, is for my boat system with my Victron stuff down there that I'm gonna install. Look at the voltage difference under massive load for a tremendous amount of time. 0.004 bouncing to 5. That is just unbelievable. Hammering this thing. It's getting hot in here. Oh, meter shut off. Still holding strong, 12.23 volts. Let's check our temperatures. 183. About 21 minutes left. We're at 55%. I'm not going to take it down too far. If it doesn't trip soon, if we get below 50%, I'm going to stop it. That'll at least give you a good idea. I would like to not ruin this. This isn't good for it, but it seems to be able to handle it just fine. But we've got to be over 20 minutes at over 160 amps now. Again, it's rated for 120 continuous. I could probably push it more, and certainly, I don't know if there's an upper limit that it's programmed to be able to put out and then we'll shut down, but it's not 160 amps. I'm assuming that, again, that temperature will probably be the first parameter to have an exceedance. The other thing I noticed, we just went through a cycle. We started at 2 cycles, I just went to 3. It's odd when you have a battery that you can see all this information, because it's amazing. I have the 36 volt battery on my golf cart, and I've used it a dozen times, but a lot of times we only use it, we start off with 105 amp hours, and we go down to maybe, I don't know, 82 amp hours remaining or 79 amp hours remaining. Very rarely, you know, do we use a lot of the capacity in the battery? And then I come in, I plug it in, I charge it up. That may not be the best thing to do, especially if I'm only, you know, down like to 82 amp hours or something. But it doesn't count those as cycles. I'm sure it has to see a certain amount of dip before it will count it as a cycle. So it's just odd how few cycles I actually use in my golf cart. You know, before I was blind on my lead acids, and I thought, you know, you kind of estimate how many cycles you would have, but now you get to see it, and it's not as many as you think, which is actually bad for lead acids, because I always assumed I got 300, 400, 500 cycles, but it's probably half of that, and they were dead and gone, you know. So let's check our temperature up to 195. I wonder if it's going to be 200. We'll see. I don't know why an engineer would have a nice round number of 200, but maybe we'll go up to see if it goes up to 200. And we're below 47%. So let's let this climb to 200, see what happens, and I'm going to shut it down. And then we'll go back and look at the historical data. Voltage is still holding strong, 12.19. Our amp draw has dropped a little bit. 199.4. So as soon as I hit 200, I'm going to go ahead and shut this inverter off. Turn a fan on because it's hot in here. Actually, I'll wait till I'm done recording, turn a fan on. Let's see if that thing kicks off at 200 degrees. 201. This thing's a monster. So it says we would have 17 minutes remaining. We've probably been hammering this thing for about 26 minutes, something like that. I'm going to kill it. Obviously, this thing far exceeds rated capacities and outputs. Let's look at historical data. Okay, so anyways, we're at 12.9 volts. Yep, 13 volts. No amps coming in or out. Same here. It says we have 46 amp hour capacity remaining. We finished at around 201.2. I wonder if that will immediately start dropping or if it will rise a bit more still. No, immediately starts dropping. Look at that. That's interesting. Yeah, look at that. That thing immediately starts dropping, so that's interesting. There's a lot of airspace in that battery, so I'm sure that's good. So recovery looks like it wouldn't be too hateful. Let's look at the historical data now. All right, so we ended, and this timestamp is every, let's see, 21:34. I want to say it was every 30 seconds. Yeah, so 21:34, 21:34, 33, 33, 32, 32. So I'm assuming every one of these intervals is 30 seconds. So this is 21:34. Let's just call it 21:34. We started off at 21:12. So about, what is that, 22 minutes? All right, so we hammered the living dog doo-doo out of this thing, you know, of over 160 amps pretty much the whole way. For some reason there was a little dip right there. That's probably as that heater was heating up, and there's a fan in there and a few other things. But for the most part, over 160 amps the entire way from 21:12 all the way out to 21:34, so 22 minutes roughly. That shows temperature, this blue line. I don't know what temperature that is. Let's see if we can tell. 170, that must have been the ambient temperature because we were over 200 on the MOSFET. So this temperature must be ambient. Capacity, this is the yellow line, is the capacity. You can see that capacity just drop. So overall, pretty impressive, I'd say. Let's hammer it. Fire it up. 164 amps. There you go. Stress test. Epoch 100 amp hour 12 volt battery, which is actually 105 amp hour battery. Exceeds the rated capacities. It's underrated, obviously, like engineering underrated for safety and longevity, but it has a little extra in there. All right, we'll do some more testing later.